So in part C, we're shown this figure 4, which shows the kinetic energy versus the potential energy of the block, cart, spring system after the block is dropped onto the cart. And what we need to state is why the two graphs must be the same. So why is this graph the same as figure 2 in part A of the question? And well, the reason is that we do no work on the system. So by dropping the block, we do not add any energy to the system. So we don't add energy to the system. Therefore, the total energy in the system must remain constant. So no change in total energy of the system. On the system. And in part 2, we're told after the block is dropped into the cart, we need to consider a system that consists only of the cart and the spring. On figure 4, we need to sketch a solid line that shows the kinetic energy of the system that consists of the cart and the spring, but not the block. So what we need to consider here is that the speed of the cart is going to decrease, and well, the potential energy will remain the same at 4 joules. So the maximum potential energy as the displacements will remain minus L and L, and the potential energy only depends on how far it goes. However, the kinetic energy of the cart is going to decrease, and it will decrease by a factor of 4. By adding this block, we have increased the mass by a factor of 4. We know kinetic energy is 1/2 mv squared, so the mass will have to decrease by a factor of 4, making it go to 1. So this is the line that we need to draw onto the graph.